Okay, so anonymous and trustless voting was the name of our project, and the idea we had for the zkApp Builder program. This presentation more is kind of a story, I guess, how we kind of went through for the weeks of kind of developing and finding answers and polishing, I guess, the whole concept. As because basically for last month we have basically had to do around like 5 different twists of all the solutions as I guess we kind of wanted to achieve a bit more than we could chew. So let's maybe start a little bit about the concept. So what we wanted to achieve and what we kind of wanted to make sure that is with implemented within our project are those requirements. So we wanted to make sure that some admin can add publicly known addresses, so the whitelist, so the addresses that are somehow verifiable that they belong to some particular group. The accounts that vote have to have a voting privileges, as well as privilege to submit proposals. What was important for us and what we wanted to utilize, one of the interesting concepts that we found out in Mina was that we wanted to create an anonymous account, somehow link mapped to the known account derived kind of that comes from the whitelist, and we wanted to make sure that this mapping between the anonymous and known account remains unknown. So the solution that we came up with for preserving that anonymity was to use basically 2 token accounts. One would be a known token account that is a token account derived from the whitelisted address that users are known from. But what these accounts can store would be a hash secret that on the moment of providing it, the secret, a user can create anonymous token account by calling basically by creating a new token account and passing the secret that that has been saved into the known account. So in just kind of workflow, the admin would register and add to a whitelist a known account. That user then will set a secret hash, secret that he will set the secret and hash the secret and save it under the known token account. So that's kind of visible to anyone and accessible. The secret itself will be a hash of known private key, an anonymous private key. So the anonymous private key in this case refers to an account that is also owned by the user, but the mapping is unknown and it's not disclosed. So in order to kind of get the setup going, that the user will set that secret and then provide this the secret calling with his anonymous account, and that can create that token account derived from our zkApp. So in this case, user kind of have 2 accounts. One is known, one is unknown. Other considerations we had that we wanted to make sure that we can kind of handle straight away. So the spam, so we want to make sure that with that access, we want to still block users to kind of for flooding of the forum of meaningless and etc. of posts. So we wanted to make sure that not cannot happen, and obviously double voting. So with just that proof of knowledge of the secret and the one that we use to create an anonymous account, that wouldn't actually safeguard us from the double voting. So how we kind of started thinking about mitigating those problems is that basically we'll have a daily submission limit. That's a submission for proposal. So users will have a daily limit of proposals they can submit, as well as we'll keep track of when the votes and make sure that the users cannot vote twice on the same proposal. And again, with all those things, we still wanted to make sure that the mapping between those 2 accounts is not visible, but can be easily proven and verified. So how we kind of started solving that is by utilizing bit tracking and that as token account storage. So we basically had two types of kind of bit tracking that we wanted to implement. Well, one is just the first, which is the bit type, the account type at the bit 0. So one account is unknown, one is known. With the unknown account, we also have a proposal count. So that will those 2 bits, 3 bits, will allow us to have a counter that it resets every day, not allowing users to spam the proposal board, as well as all the voting votes within the rest of the first field element of storage that we'll use for just switching if the vote already happened for proposal for the proposal ID. And then again, we'll have the hash of a secret key. It could be, I guess, in a separate field element as we don't utilize another state, and we still have 6 left to utilize on the known account. I didn't want to jump to the code, so I just put some screenshots of the code in here. So that's functions for the known account, and here are the functions to keep track of submissions and votes on the unknown account. Because I'm gonna go through the code. So that's one of the first problems that we think we solved to some level, conceptual at least. But obviously that doesn't solve all our project problem, and that kind of comes, and I think many other applications and developers have a problem with trying to store a bit more information than just 8 field elements. So few of our ideas to do it. So simply first, we were kind of trying to become mega purist and try to keep all our data on chain. Maybe it might be a bit against the Mina idea, but we thought it would be pretty cool to give it a try. But that kind of became a rabbit hole. But the one of the ideas we had to achieve that would be to use the other token accounts state that we had to accessible, and kind of keep the ANA's counters within the token, so the proposal creator token account, and also utilize bit packing so we can squeeze quite a bit more of those counter. And then on top of that, well, obviously off-chain storage, Merkle and IPFS, ideally or BDB, which was basically the next step of our journey. Just to kind of reiterate on the idea itself, how we wanted to utilize the off-chain storage in this case, still utilizing our known and unknown token accounts. So for creating proposals, user would only use at this point his anonymous token account, because we can at any point verify that that account is actually, we can prove that it can create proposals. We increment proposal counter on our zkApp, just the kind of ID. And then we upload the proposal body to IPFS. That would be just simple IPFS, because the proposal body would not ever change. And then after that, we'll create an entry in our BDB database that will be referenced through proposal CID. So that CID, that basically a function body, and in the value we'll keep a track of the votes, or yay or nay. And then as well, we'll create a Merkle tree with all the proposal CIDs within our zkApp, and we'll put that location on the tree, and we'll keep updating the Merkle root alongside with proposal counter if there are new proposals. And then when it comes to vote on proposals, so another user will pass well his private key, proposal ID, and a vote. We'll again verify that the user is able to vote, and we'll update his voting, so we make sure that he cannot double vote at this point. And then again, we kind of retrieve the proposal ID that he's looking for from our Merkle. We'll reference it. We'll go to our BDB using the CID itself, and we'll update the yay and nay vote. So basically, that this required from us utilizing RBDB and IPFS. And as I said, we kind of wanted to stay with on-chain storage without trying to utilize or trusted oracles and the kind of TLS oracle that's not kind of there. We wanted to solve storage proposals in some way. But token accounts cannot really store that much information. So we kind of bring back and we thought that, basically off-chain storage is the must in our case. The problem of off-chain storage that kind of came up from there, I guess there were a few. First of all, the simplest way we could figure out how to do it to make it fully trustless would be verify that whenever user is updating IPFS, we can actually verify that the raw data that he's uploading is the data that he's saying that he's uploaded. And in order to verify that, the required step would be to have a snarky.js CID generation proof. So CID is that unique identifier of IPFS files. And in order to kind of fully trustlessly be able to retrieve that, we'll have to have that implemented within the snarky.js. The way to do it is to add multi-codec type to IPFS repo in the case how we actually practically do it. And when we kind of came to research that, it went way above our heads. So we unfortunately failed there. Another thing that would be very useful to have in order to make sure that no one else is able to modify the files on the RBDB or IPFS due to the information that RBDB and IPFS, IPFS generally can be updated at any point by anyone. What with RBDB, there are ways to put access control around it. Identity provider is one of the solutions that can do it. Unfortunately, the only identity provider that we know of that could be somehow implementable in this case would require Ethereum keys. And obviously Mina does not support it, so there will have to be the keys by the Mina keys will have to be supported again by identity provider. Unfortunately, identity provider itself has not been maintained much, and as far as I understand, even the Ethereum now keys are having some problems to actually be used as a proper access control. Another way to do access control is to create a trusted oracle, and that will just I think use the tutorial 4 or 5 that just pings to a local server of the oracle.
A couple of minutes.
Sorry.
Is 2 more minutes? Is that enough time for you?
Yes. It's wrapping up. So unfortunately, the problems with token accounts we weren't able to solve. That kind of stopped us, and mainly with kind of linking all of our pieces together. We're trying to get to know the API that allows us to actually update the app state of the token account. We try to have some answers from the team, but it took quite a while, to be honest, and we couldn't be able to totally solve that. So here's just a few of the tries we've been trying. I've been quite dreadful trying to figure out how to exactly update it, and unfortunately we never be able to do it. We know it's possible, but I mean we weren't able actually at the end to achieve that. And that's pretty much wraps it up. We basically have a lot of spread around code pieces that we weren't able to glue together. I think our main problem was the token account and us being maybe too much switched on, trying to utilize it fully, and then B, the RBDB and IPFS. Conceptually, it totally works, but unless the CID generation can be somehow proven within the snarky.js circuit, or a way to verify that RBDB can be accessed only via only via zkApp. I think those two main things are missing from our project. Yeah, I guess I will take any questions. Yep.
Yeah. So I'd just be interested in what were the problems that you hit when trying to use trying to update state on token accounts.
Yeah. So as kind of we understood the way to so we were successfully able to create the token accounts and use the transfers and move the tokens around, and I think I even was able even to update the permissions of that token account. But when it comes to app state itself, literally the body update, I wasn't able to do it. I kind of think there is some solution using the approve method, because if I understand it correctly, in order to allow another zkApp to transfer tokens, you can approve it within the transaction. So I would think updating the app state of that token account will be possible within in similar manner. But every time I was hitting that permission, even if all my the permissions I was able to set, I was always trying to set it to the none. So it's kind of open at least for testing, trying to achieve that.
So, did you add a signature to?
Yes, so all of those code snippets on the bottom of the method, they had this dot require signature, and I even was trying to pass all the private keys I was ever using with my tests. Show some code.
Okay, we should look at it.
Sure.
Yeah.
I think the one thing that Jack mentioned to me was that the app state, there is a way to update this app state, but it requires signature, but cannot be done with a proof. And so I kind of always was trying to use signature, but at some point I tried even just to use proofs, and that also didn't work. So maybe most likely actually there is a problem with my my calls, my methods some way. But yeah, if at some point I will be able to find out, I think that would be very useful.
We should find out, definitely. Seems like an important problem to solve. I think you need a proof for the zkApp and the signature for the account whose state is set.
I see. Yeah, I was trying to mix those two, but yeah, yeah, I think the token account storage is actually, again, I think we kind of came up from like very focused way of trying to store a lot of stuff on chain, and maybe I know it's not the way that everyone sees it, but we kind of wanted to kind of think of it as a critical applications that we do want to have that information on chain. And because of that, we feel there is a lot of value in the token account, because that just allows every user's kind of personal storage, which I think is quite useful thing.
Yeah, totally. I fully agree. It's great that you explored this. Thanks.
Cool. Yeah, amazing. Yeah, thanks, guys.